Hello friends, welcome you all to the next lecture of the JCE Connect series of online lectures. We are into module 3 and dealing with moment and its applications. In the previous videos we have seen or we have studied what is a moment. Further we have studied what is a couple, understood the characteristics of the couple. Then we have studied Varignon's theorem. We have done the application problems of moment and couples. Then in the previous video we started with the first example of non-concurrent coplanar force system, where in detail or in depth we have seen how a number of forces acting about a plate are causing a reaction with respect to the given point, and we were able to find the magnitude, direction as well as the location of the resultant. So, now let us go ahead with the third example. Second example was given to you all as an homework. Before that, let me brush up once again the points which are required by you all to solve these examples. Again, the first is a general statement which says that in case of coplanar non-concurrent force system, we can find the magnitude, direction as well as the line of action, or the position of the resultant can be easily determined. Then it is a 4-step procedure after this, in which up to the first 3 steps the things are common, that is up to finding the resultant r and direction of the resultant theta, wherein we take summation fx square, summation fy square, and resultant is equal to the square root of summation fx square plus summation fy square. The angle theta is given by theta is equal to tan inverse of summation fy upon summation fx. Then the last point is the most important point, wherein we will be using the application of Varignon's theorem to obtain the x ordinate and the y ordinate. So, with this brief introduction, let us start with the today's example. So, again in each example I am trying to introduce something new. Hopefully you will cope up with it. Okay. So, here we have a lamina. For the lamina of 40 mm by 40 mm divided into equal sized squares subjected to forces as shown in the figure, obtain the magnitude, direction and line of action of the resultant of the system with respect to point O. Okay. So, here is your point O, which is the origin. Now, the things which you need to understand is the square plate is of size 40 by 40, hence each unit will be of 10, okay, 10, 20, 30, 40. So, each unit will be of 10 mm. Similarly, vertically also each unit will be of 10 mm, hence the plate is 40 by 40. So, second important thing to be noted here is the angle theta 1 and theta 2 are not directly given, but the projection of these forces are given in this square. Okay. The projection of these forces are given in this square. We have to use this distances, that is the height and the width, to calculate the angle theta 2 and theta 1. So, this is a different example in which you need to first find the angle and then start with the solution for the example. So, let us start with the solution for this example. So, first is the resolved diagram, wherein the inclined forces of 200 and 400 kilonewton are split up into 200 cos theta 2, 200 sin theta 2, 400 cos theta 1 and 400 sin theta 1. Okay, the other forces are kept as it is. So, as you see here in this image, one force is acting inwards and other force is acting outwards. Okay, so please be careful while resolving. For this force which is coming inward, the components are coming inwards. For this force which is going outwards, the components are going outwards. Okay, and here there are two forces now, because 1000 force was 100 Newton force, sorry, was already existing at this point. Further, what has happened? The resolved component has also come on it. So there will be two horizontal forces at this point. Okay, so be careful. Next, how to calculate the angle theta 2? Now theta 2 will be opposite upon adjacent. Now for theta 2, this triangle, this will be the opposite, that is the vertical distance. Okay, so this vertical height is nothing but 40 because it is covering entire height. So this is 40. Horizontal is made up of how many squares? 2 squares. This line, so it is 20. So it is tan theta 2 is equal to 40 by 20. Theta 2 is 63.43 degrees. Now theta 1 and theta 2 have to be correct. If these both angles are not correct, entire sum will go wrong. Similarly, how will you calculate theta 1? Again, tan theta is opposite upon adjacent. Now opposite, see how many squares? 1, 2, 3. That means the opposite is 30 units. Now adjacent, how many squares? Only 1 square. That means adjacent is only 10 units. Therefore, tan inverse of 30 by 10. So here we get theta 1 as 71.57. So further remember that theta 1 is 71.57 and theta 2 is 63.43 degrees. So note down theta 1 and theta 2 which we have to use in the example further. So check out these components also. The horizontal component is 200 cos theta 2, vertical component is 200 sin theta 2. Here the vertical component is 400 sin theta 1, horizontal component is 400 cos theta 1. So here with the signs I have put up the values so that it will be easy for you all to get the answers. Be careful at this point where you have two forces moving along positive x axis. Okay, this force coming down is marked as negative, this is also negative, this is positive, and this force is also positive as it is moving rightwards. So let us find the resultant which is given by summation fx square plus summation fy square. So summation fx will be addition of all the horizontal forces. The forces which are moving rightwards are taken as positive and those forces which are moving leftwards are taken as negative. So luckily here we don't have any negative force while computing summation fx. All forces need to be added. That is 150 plus 400 cos theta 1 is 71.57 degrees plus 100 and plus 200 cos theta 2 where cos theta 2 is 63.43. Similarly, get the summation fx which is the addition of all the forces moving vertically, that is either vertically upwards or vertically downwards. So now here the forces which are moving vertically downwards are taken with a negative sign and the forces which are moving upwards are taken with a positive sign. So let us find summation fx. Summation fx goes very easy, minus 250 minus 400 sin theta 1 plus 200 sin theta 2. So we get summation fx and summation fy. Summation fx is positive, summation fy is negative. So the course of the resultant is in the third direction. So resultant value is square root of summation fx square plus summation fy square. We get the answer as 648.169 and the value of theta we get it as minus 44.04 degrees. So here again the first stage gets over where we have applied our basic knowledge and found out the resultant and its direction. Okay. resultant, magnitude of the resultant and its direction, and yet we have to find the location of the resultant, which we will be doing now. For that we require to compute the moment with respect to our reference point O. Now again, the easiness in this example is these two forces, as they are originating from O itself, they will not produce any moment. This force when extended passing through O, and this force will not produce any moment. Similarly here, these two horizontal forces 400 cos theta 1 and plus 100 Newton, both these forces pass through point O, hence they will not cause any moment. Now the forces which can cause moment are 150, which is horizontal force, vertical distance will be 40 units, and this vertical force which will move like this towards point O, and horizontal units are again 40. So let us look into the moment diagram. So this is the first moment. See the arrow, it is going clockwise. Okay, once again I will repeat it. How is the moment? That means how is this 150 force going to rotate about point O? Clockwise direction. So what will be the magnitude? Horizontal force is 150, vertical distance is 40, 150 into 40 with a plus sign. Now the next force which will cause moment is 400 sin theta 1. Again this will also move in the clockwise direction. Okay, this will also move in clockwise direction. So here once again, yes, arrow is moving in clockwise direction. So only two moments here, only two forces cause the moment. So this is the simplified diagram which has the resolved components only, which we need to take into consideration for counting. So moment equation, only how many forces cause the moment? Two forces only cause the moment. We have to forget about these two forces easily because they are originating from point O itself. 250 is there, but there is no distance to be multiplied, it also goes. Okay, so only the moments are caused by this 150 Newton force, which will move towards point O in a clockwise direction. See here a positive sign is mentioned and this arrow is clockwise. Similarly, 400 sin theta 2 force will cause a moment again with respect to point O itself. Okay, it is clockwise direction. So once we get the summation of moments, what we have to do is obtain the x-intercept and y-intercept, which is a very easy task. X-intercept will be summation of moments divided by summation Fy, and y-intercept will be summation of moments upon summation Fx. Okay, so you get the x and y intercept. So what all we have done in this example? In this example, firstly we calculated the theta 1 and theta 2 values, where you have to be smart and use your common sense. Then further we developed the equations for summation Fx and summation Fy, calculated the resultant and the angle of the resultant. Then we came to the next part, that is application of Varignon's theorem, wherein we have found out the exact location of the resultant, that is x and y coordinates. Hopefully you have understood the things taught and you have solved the previous example. Now take this one more example for homework. If you get doubt in this example, you will get doubt, you have to text me personally and get your doubts cleared. So this homework submissions and all, I am properly maintaining them, and this will be only for your assignment records. Okay, this will make one part of assignment records for sure, and I won't hesitate in giving less marks for those who don't complete the homework in time. hopefully you all will complete the things in time. So let me take a leave for the day. Take care. See you tomorrow with the further videos. Bye.